11-1, square roots and irrational numbers, part 2, something like that. All right, we're going to talk about different sets of numbers right now. First kind of set we have is the natural numbers. These are the natural counting numbers, the ones that you kind of learned when you were first starting to learn how to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. Whole numbers is just basically the natural numbers plus 0. So 0, 1, 2, 3, 4, 5. Integers are adding the negative numbers. So positive or negative natural numbers or 0. So -3, -2, -1, 0, 1, 2, 3, 4, 5, -20, -1 million. All of those are integers. Next, you have your rational numbers. Those are any number that can be written as a fraction. And we'll talk more about those in a moment. You then have your irrational numbers, and those are any decimal number which cannot be written as a fraction. It's non-terminating and non-repeating decimal. So let's talk about those a little bit more. Oh, sorry, forgot the reals. Can't forget the reals. Those are basically everything. Rational and irrational. So if you can come up with a number, it's a real number. So let's talk about our rational and irrational numbers. How are they alike? How are they different? They're not alike in any way, shape, or form except they have digits. So rational numbers make sense. Rational means logical, it works, it makes sense, it's understandable. Irrational means crazy. It doesn't make sense. If someone's being irrational, they're acting crazy. They're not making sense. They're hysterical. So irrational is crazy. So rational numbers are any number that can be written as a fraction. So 2/3 whole numbers can be written as a fraction. Remember, we can put 7 over 1. Integers, we can have negative numbers. Negative numbers can be written as fractions by putting them over 1. Terminating decimals. 0.49 could be 49 over 100, so it can be written as a fraction. Repeating decimals, decimals that go on forever and repeat. So 0.77777, that's 7/9. So all of those are rational because they can be written as a fraction. Irrational numbers are non-terminating and non-repeating decimals. So think of your parents when they're mad at you. They just keep going on and on and on. And if they're really good, they never repeat. They keep saying different things, but they never stop. So these cannot be written as fractions. Example would be pi. Pi is a irrational number. I know we're all used to seeing it as 3.14, but that's just an abbreviated version. It's 3.14159, blah, 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 blah. It goes on forever, and there's no repeating, no terminating. So there's no pattern to it. It just keeps going. Square root of 3, really the square root of any non-perfect square number. So square root of 3, square root of 2, square root of 5, square root of 7, square root of 8, square root of 17. They keep going, and so they are irrational numbers. Now, don't confuse those with the perfect squares. Like the square root of 25 is 5. That terminates. So that's okay. It's when you can't take the square root of it. This looks like it has a pattern, but you can't take one chunk of it and move it over and have it match up with another chunk. So we have 2, 1, 2, 1, 1, 2, 1, 1, 1, 2, 1, 1, 1, 1, 1, 2, 1, 1, 1, 1, 1, and so on. There's no pattern that you can say this part is like another part of it. Or 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's a pattern, but it's non-repeating. And it doesn't stop. Remember those little dots at the end mean it doesn't stop. And here's another possible one. So you can see, you can come up with all kinds of different patterns. That there's a pattern, but it's not repeating. There's a difference. Okay, so take a look at these, and I would want you to identify, are they rational or irrational? I'll give you a second to do that. Okay, number 1, is that rational or irrational? Correct answer is irrational. The square root of 10 is somewhere around 3.1 or somewhere around that, but we cannot take the square root of that. Number 2, square root of 25. That is rational. The square root of 25 is 5, which we can write as a fraction, 5 over 1. Number 3, square root of 15 is irrational. Can't take the square root of 15. The negative square root of 49 is rational. Square root of 49 is 7, but then that's going to be the negative in front makes it a negative 7. And we can have integers integers are rational numbers. 7.22222. Did you say rational or irrational? Hopefully you said rational because it is repeating. There is a pattern. Number 6, square root of 62 is irrational because you can't take the square root of 62. Now, this is basically what we did in the last lesson. I want you to estimate these to the nearest integer. So the square root of 8, remember that's going to be between the, well, I'll give you a second. Why don't you go ahead and try these 4 if you remember how to do them from the previous lesson. All right, number 1, square root of 8 would be the closest that would be it's between the square root of 4 and the square root of 9. So it would be approximately the square root of 3. Number 2, square root of 17 is between the square root of 16 and the square root of 25. Those are both perfect squares, and we would say that's approximately 4. Number 3, the negative square root of 24 would be between the negative square root of 16 and the negative square root of 25. So we'd say approximately negative 5. And for square root of 26, it's between square root of 25 and the square root of 36, and it's closest to 5. So how many of those did you get right? Hopefully all of them. If not, ask questions. Okay, so we have these 3. I'd like you to give them a try, and I know you haven't seen these before, but at least in your head you should be able to do 1, maybe 2, and the third one might be a little bit tough. So for number 1, I think hopefully everyone got that one. We can simplify that one. That's 12. 12 times 12 is 144. Now for number 2, go ahead and add those together, and then the square root of 25 is 5. Now for number 3, this is the one that might have given you a little bit of trouble, but take the square root of 16, take the square root of 81. Square root of 16 is 4, square root of 81 is 9, and we'll get 4 9ths. So still doing the same stuff. You're still taking the square root, but you're taking the square root of each part. Would you try these 3? I'll give you a moment to pause and then to give them a try. Okay, so for number 4, you should have gotten the negative 7. The negative square root of 100 is negative 10. And for number 6, we can break up that into the square root of 36 over the square root of 64. So that's going to start out as 6/8. I would want you to simplify that, though, to 3 over 4, or 3/4. How many did you get right? That's the question. And if you didn't get it right, you need to be asking the question, why? And asking me that in the next class. Okay, kind of going back to the beginning. Identify each number below as rational or irrational. So number 1, and I'll give you a moment to do these, and then come back and see if you got them right. Number 1, 7/8. For a number to be rational, you have to be able to write it as a fraction. Well, that is a fraction, so it's rational. Number 2, 0. That's a rational. We can write that as a fraction as 0 over 1, or 0 over 2, or 0 over 100. It just says we have 0 parts of a fraction. Number 3 is an integer, therefore it is a rational number. Number 4, square root of 41. That's not a perfect. 41 is not a perfect square, so that's irrational. Number 5, we have 8. We can put that as 8 over 1, which makes it a fraction, so it is rational. How many of those did you get right? Hopefully all of them. Again, if you're not sure about something, don't forget to ask me in the next class. Would you try these 5 problems Tell me if they're rational or irrational. I'll pause the video and come back when you're ready. Number 6 is rational because it's a fraction, and that's fine. Number 7 we can write as a fraction as -9/1, which would make it rational. Number 8, the square root of 49 is 7, which is a whole number, which we can write as 7/1, so it's rational. Number 9, the negative square root of 25 is -5, which we could write as -5/1, making it a fraction, making it a rational number. Square root of 8, can't do the square root of 8, and it's not 2. 2 times 2 is 4. So this is an irrational number. If you have questions, don't hesitate to ask. And that's the end of the lesson. Hopefully you don't have any questions, but if you do, let me know. If you see any mistakes or anything major, let me know, and I will talk to you later. Thank you very much. Bye.